Physical science is the study of non-living things.
a long holidays. If you'll be having a question during the lesson, please call, WhatsApp us on 063 629 3655. Let me repeat the number again. Please, if you'll be having a question, please WhatsApp us on 063 629 3655. Let me repeat again so that you get it. 063 629 3655. Today, grade 12 will be looking at capacitor and capacitance. We know that we need to always go back to the structure of the examination, because now we're preparing for prelim that will be coming soon, and also for final exam that will be coming in the fourth term. Mechanics, the paper one is situated like this, grade 12s. Mechanics, it has 90 marks and it weighs 62%. And then electricity and magnetism, it has 33 marks, which it weighs 22%. Wave, sound and light, it has 24 marks, which weighs 16%. The total marks of the paper, which is paper one, is 150 marks, and you'll be writing for 3 hours. We continue by saying the paper one will be summarized in this manner. We have 10 multiple choice questions, which takes 20 marks. Section B will be structured or a long question, which is out of 130 marks. And in the paper, as we said, is out of 150 marks. And the duration of the paper is 3 hours. That means after 3 hours, we stop you. You can't write anymore. Okay. And the topic that we'll be dealing with today, out of 150, it takes 18 plus minus 18 marks. Capacitor. What is capacitor? Define a capacitor as a device for storing electrical charge. That means when we ask you in exam to define a capacitor, in simple terms, you must say it's a device that stores electrical charges. Are we together, grade 12? And then this is how our exam guideline define capacitor. And then because we have a capacitor, we'll be having capacitance. We say capacitance is made up of a capacitor. A capacitor is made out of two plates separated by a dielectric or insulating material. Insulating material can be anything. It can be air, it can be paper, it can be glass, it can be plastic. That means when we talk about dielectric, we're talking about what? Insulating material. Are we together, grade 12s? We say, where do we use the capacitors in real life? Capacitors, they are used in technology for what? Like for instance, we found capacitors as a component that is used as a filter in a circuit in a power supply. Or also is what? Is separation. It used to separate the frequencies between the hoover and the hoover of the speaker and the tweeter. That means it gives you the high pitch. Are we together? That is where capacitor is used in technology. And lastly, it is used in what? Filtering the noise. Like for instance, the reason why because now we have a good quality capacitors. That is why when you buy a sound system or a TV, you can hear what the sound clearly. Unlike in the olden days, because our capacitors then they were not of good quality. Grade 12s, When you open your TV or your system, you'll find something like this. This is what capacitor looks like. If you find anything looks like that, you must know that it is what capacitor. You can see that they comes in different shapes and different size. It depending on what, on the device that you found it. Are we together, grade 12? We continue. This way, what you see here are the formulas that we'll be using to calculate what? Capacitance. Are we together, grade 12? And these formulas, they come from exam guideline. We didn't think them by themselves or by ourselves. We say the first one will be, let's look at this one here, which says C is equals to Q over V. That means in this formula, to calculate capacitance, you need charges. We need a charge and a voltage. Are we together, grade 12? And then we'll be looking at this formula. Before we look at this, I want to look at this one, the simple one. Here we'll need what? It depends, to calculate the capacitor here, we'll be looking at the area and the distance between the plates and the permeability of a free space. What you see here, this E with a subscript O is what? Permeability of a free space. And A is for what? Is for area, and D is for distance between the plates. Okay, and C we said is for what? Is for capacitance. And then when you look at this formula and this formula, there is only one difference. This is the difference is this. It's K. K is for what? We say K is the constant of what? Is the constant of the material, of the material that's used to make the dielectrics. Changing the material, it means you change the value of K. Like for instance, I forget to tell you about the permeability of a free space. Permeability of a free space, it's a constant. It is equals to 8,85 times 10 to the exponent negative 12. Are we together, grade 12s? Yes. You'll see as we go on. Like for instance, this formula is the one that we started with, that say a capacitor is equal to a charge divided by what? By a voltage. And then this formula, when you look at it, it means that when you increase the voltage, that means you are decreasing what? The capacitor. But when you decrease the charge, also you'll be decreasing what? The capacitor. That means you can see that the capacitance and the voltage, they are define capacitance as the amount of charge it can store per volt. Are we together? We're looking at what? The amount of charge. When you see this Q, it means what? The Q there it is for what? Is for the amount of charge. And then the V is what? Per volt. Are we together? We're talking about voltage. Okay? We can see there we're saying what? C stands for what? It stands for a capacitance, and it is measured in F. F is what? Farad. F stands for Farad. Are we together, colleagues? It's from our scientist, Farad. He's the one who discovered the capacitor. Okay. And then now Q, it stands for what? Charge. The amount of charge. And it's measured in what? The charge is measured in coulombs. Are we together? It's measured in coulombs. Then we go to the voltage. V stands for what? Voltage, and it's measured in what? In volts. When you see V, you know that is what? Is volt. And when you see C, you see we have a, don't confuse this C with this C. This C is the unit. It's the SI unit. It stands for what? Coulombs. Are we together? And this C that you see here, it stands for what? Capacitance. Are we together, grade 12? Yes. We go on. We're looking at another formula. The two formulas that we talked about before. Let's start with, when you look at these formulas are grade 12s. You don't have to memorize them. Each and every test, each and every exam that you'll be writing, you'll be given a formula sheet that contains these formulas. What you need to know is to know what you need to do is to do what? To know when to use each and every formula. Are we together, grade 12s? Yes. Let's look at the what does this formula mean to us. Are we together? We'll look at both of them at the same time. You see, this C is the same as this C, grade 12. Are we together? Then we say C stands for capacitance, and it is measured in farad, as we said. And then E epsilon O, or subscript O, stands for what? Permeability of a free space, and it is a constant. Constant, it means it doesn't change. Whether it's a Christmas day, whether it's a Good Friday, whether it's Sunday or Monday, it doesn't change. It always remains the same. It remains what? 8.85 times 10 to the exponent negative 12. And then it is measured in what? Farad per meter. Farad per meter. Are we together, grade 12? Yes. And we say A, which is this A. This A that you see here is the same A that you see there. It stands for what? The area of the plate. We said at the beginning that capacitance is made up of two plates which are separated by what? Dielectrics. Are we together, grade 12? That means you'll have two plates like this. And then you can see that the distance here, there is a distance between the two plates, and then the distance, the space between the two plates, that's where you get what? Dielectrics. A dielectric is any insulating material that you can use. It's either air, it's either plastic, it's either paper, it's either glass. As long as it's an insulating material. Remember, what is an insulating material? Insulating material is the material that do not conduct electricity. Are we together, grade 12s? It's a material that do not conduct an electricity. Are we together? Yes. And then we come to D. This D that you see here is the same as this D. It stands for what? The distance between the plates. Are we together? As we know that we said this is the plate, this is the plate. The distance between these two plates is this D. And then between this plate, you will find that we have what? We have a dielectric material, which is an insulating material. Are we together, grade 12? Yes. And then we continue by saying, by looking at what K. This is the same K that you see here. Is also a constant. If you use a one material, that means you'll get the same value. Are we together? It's a constant. It's what? It's a constant of what? Dielectric material. Are we together? Each and every material that we'll be using, it has its own value. Are we together, grade 12? Remember that each and every material that you use to make a dielectric it has its own value. You'll see as we go forward. Okay, now we have symbols. We say we will use the above equations to calculate the following. Like for instance, the formulas that you saw, all three formulas that you saw above. Let me just go back to show you this formula, this one, and also this one. All these formulas, we use them to calculate what? We're going to use this formula to calculate capacitance. We're going to use them to calculate what? Area. We're going to use them to calculate what? Distance. And lastly, I don't see it to calculate what? Voltage of the capacitor. Are we together? We'll also use these formulas to calculate what? Voltage. You can see that the first equation has what? Has V. That is a voltage. That means from this formula, we can easily calculate what? Voltage, charge, and capacitor. Are we together, grade 12? Yes. Yes. Yes, you can see here, you'll be able to calculate what? Voltage. You'll be able to calculate what? Charge. You'll be able to calculate capacitance and area, not forgetting what? The distance. Are we together, grade 12? Okay. Let's continue. This is how we draw a capacitor. Are we together? You can see here, we say what? Okay, let's firstly, before we look into the capacitor, let's look at the factors that affect the capacitor. We have three factors that affect the capacitor. Whether the capacitor to do good or to do bad is affected by these three factors. The first one is the area of the plate. That means, grade 12, if you have a small area, if you have a small plate, that means your capacitor will not store more charges. Are we together? If you have a small plate, that means you'll have what? Fewer charges. Remember, a capacitor, what does? It stores electrical charges so that we can use them later. Like, for instance, we can use that charges later in the circuit. Okay, and then if like you start a small fewer charges, that means when you start using that capacitor, the charges will be depleted within no time. But if you store more charges, that means you will be able to use that capacitor for longer because you have more charges. Are we together, grade 12? Yes. And then we're looking also at what? At the distance between the plates. If the distance between the plates is smaller, that means we'll have more capacitance. Are we together? If the distance is bigger, that means we'll have what? If the distance is longer, we'll have less capacitance. Because we get that from this formula. C is equals to over D. You can see that here, distance is inversely proportional to the capacitance. That means increasing the distance, you will have what? Increasing the distance, you will have less capacitance. Are we together, grade 12? And then also the area of the plate. When you increase the area of the plate, you'll be increasing what? The capacitance. Are we together? Because capacitance and the area, they are directly proportional to each other. Are we together, grade 12s? Yes. We look at this formula. That means when you decrease the area between the plates, that means you'll have more capacitance. You'll have bigger capacitance. Are we together, grade 12? And then if you decrease the area of the plate, that means grade 12, you'll have what? Less capacitance. Are we together, grade 12? Yes. And also, grade 12, the dielectric constant of the material between the plates, which is what? K. Are we together? The dielectric constant, if you change from one material to another, like for instance, when you use air as your dielectric, air has the K for air is equals to 1. Are we together? Yes. And you find that when you use plastic is the K is bigger. Are we together? That means when you use air, you'll get less capacitance. But if you change from air to another material, you'll have what? Bigger capacitance. That means the dielectric constant, it does take part. That means the material that we're using to make this capacitor, it makes a big impact on the capacitance that will be produced by the same capacitor. Are we together, grade 12? Don't forget, grade 12, if you want to send us any question, please WhatsApp us. We can only deal with WhatsApp at the moment. The number is 063 629 3655. Are we together, grade 12? Don't use the number 063 629 3655. Okay, grade 12. Now we go to what? To look at the capacitor. How does capacitor look like? You can see we have a plate A and plate B. We have two plates, and then in between there is a distance. Can you see the distance between the plates, the way it is? Are we together? There must be a distance between the plates, and you can see the dots that you find between the plates is what? It is a dielectric. Are we together? It is a dielectric, and it can be any material, or I can say it can be any insulating material. Are we together? And then we say different material, they have different what? K value. Different material have different K value. Are we together? Yes. And then we'll be able to do what? It is important that we calculate what? The area of the plate. The area of the plate, it is very, very important, especially when we're using this formula, because this A that you see there is the area of the plate. And then we make sure that in most cases, we make sure that the plate, both plates are of the same size. Are we together? We make sure that the plates are of the same size. Okay, this is what the K that we're talking about. Are we together? You can see that the different material have different what? Value of K. As I mentioned that air is equal to the K for air is 1. Are we together? That means if you'll be using air as your dielectric, that means for K you're gonna put what? 1. Are we together? And other materials, they differ. Like for instance, paper. The paper, we have a range of K is gonna be 2.0 to 6.0. Are we together? depend on what kind of paper are you using there. We know that we have a different papers. We have a tissue, we have a toilet paper, we have a cardboard, we have a paper that we use to photocopy, we have a paper that we use in the exercise books. Those are different papers. And those different papers, they have what? Different what? Dielectric constant. Are we together, grade 12? Yes. Let's continue. And we also look at what? Plastic. Plastic also, it starts, the dielectric constant for plastic, it starts from 2.0 to 6.1. Sorry, grade 12, here it's supposed to be 6.1. Are we together? It's 6.1, not 6.0. It's 6.1. And then that is plastic. Remember, we have a different plastic also. We can see that we have a lot of material. Even in the shop, when you go to the shop, you will find lots of material that are made of plastic, and that plastic are different. Plastics are different. And then the reason why we have the range from 2.0 to 6.1 is because of what? We have a different plastics. And also, when we go to glass also, you can see glass starts from 4.8 to 8.0 grade 12. So, which again, because of different types of glasses that we have. Now, yes, we have different types of glasses, and also because of that, the dielectric constant is different. Are we together, grade 12? Thank you very much. And then we go to polystyrene. Polystyrene, you see the glasses that the white cups. The white cups that we use for tea, like for instance, you buy them in bulk in shops so that you can use them to drink cold drink at parties, or sometimes we use them to drink tea. Those white glasses, they are like plastic-like, and then it bends easily. That is polystyrene. You buy them at shop for parties and whatever. That polystyrene, it has dielectric constant of 2.6. Are we together? And grade 12, please don't stress for memorize this. If they want you to calculate using different materials, they will give you the value for that K. Are we together? They'll give you the value for K. Are we together? And they'll tell you what kind of material is that, and they'll give you the value for K. Are we together? You don't have to memorize all of this because you have so many materials. This is not only materials that we have. We have so many materials that you can use as a dielectric in the capacitor. Then this is an example. I just did this for an example. Are we together, grade 12s? Yes. Let's continue. We have our first example. In our example, we say a 0.01 farad capacitor. This is the capacitance. This is for C. Are we together? This is C that you saw in the formulas. Capacitance. And we have what? Capacitor has a voltage of what? 20 volts DC. What is DC stands for, grade 12? DC is a direct current. Is the current from batteries, not from plugs. It's not from the plugs. We said applied across its plate. What is the charge in coulombs? At this moment, remember the formula says C is equals to Q over V. This is our formula. Are we together, grade 12? Then we say now, because now they ask you to calculate what? Charge, which is Q. Are we together? They ask you to calculate charge. Grade 12. If you have this kind of a question in the exam or in the test, please don't start by writing this formula. This formula, it's not wrong, but we're saying copy the formula the way it is given to you from the formula sheet. In the formula sheet, you'll get this formula. Are we together, grade 12? The formula will be given like this. And then after you copy it down from the formula sheet, you do what? The second step is to do what? To substitute. Now, firstly, I always I tell my learners that you must write down the given data. You look at the statement and then you found values. Those values, you need to write them separately. So, are we together? Like this. You just write data, then you say, okay, you just say data, then you write. Or you look at 0.01 farad. We said, what is farad? Farad is the SI unit for what? Capacitance. Okay. Then now we're going to write what? C is equals to 0.01 farad. 0.01 farad. And then we have another value, which is what? 20 volts. What is volts? Volts is what? Voltage, okay, which is 20 volts. Then you look at what is being asked you to calculate. Then they ask you to calculate what? Charge. They ask you to calculate charge. Then we know that charge is Q. Then for Q, we put what? Question mark, because the reason why we put in question mark is because we don't know how much is charge as yet. Are we together? That is why we are calculating charge. We're calculating for charge. Are we together? Then from this formula that you copied from the formula sheet, this is what you have to do. You have to do what? To substitute. You don't work on the formula before. You don't make the subject of the formula before you substitute. You will lose marks. Grade 12s. Then we say now for C, C is equal to what? 0.01. That means when we see C, we put what? 0.01, which is equal to charge, which we are calculating for. Can you see? Because I don't know how much is charge, I didn't leave empty space. I did what? I write what it's supposed to be calculated. Are we together? I know when we mark your scripts, we'll find that because you don't know how much is charged, then you don't put anything. Then if you don't put anything, grade 12, what are you calculating? It is important that you write Q, you write whatever is asked from you to calculate. Now at this moment, they ask you to calculate what? Q, which is the charge. Are we together? Then we say divided by what? But divided by voltage. Voltage, which is how much? 20. Can you see? I've managed to substitute everything in that formula, grade 12s. Are we together? Then from there, you can now start to do what? To manipulate. Are we together? You can start to manipulate by doing what? You can multiply. You can say 0.01 is equals to Q divided by 20. Then we multiply both sides by 20, both sides by 20. Are we together? Then this 20 will cancel this 20. Why are we multiplying by 20? That is a mathematical rule that say whatever you do on the left, you must also do on the right. And another thing that forces us to do this is because of what? We want Q to be alone so that we know how much is the value of Q. Are we together? And you can see that if after we do what? We cancelled this 20, then we're left with what? Q is equals to 20 multiplied by 0.01. Then you can take your calculator, grade 12, and now punch in 20 multiplied by 0.01. Then you'll get this value here. You'll get this value, which is 0.2. And it is very, very important, grade 12, that you write the SI unit at the end, because if you don't put the SI unit, if you don't put this C, which means columns, that means we're not going to give you mark for the answer. Are we together, grade 12? We're not going to give you the mark for the answer. That means, how do we mark? We'll give you 1 mark for the correct formula that you chose. We give you another mark for what? For substitution. And then the last mark is, it comes from what? The answer, the final answer, and the SI unit, which is coulomb at this instant. Are we together, grade 12? Yes. If you forget to put coulombs here, then you must know that we're going to give you 2 out of 3 marks. Are we together? That means you lost 1 mark and your answer is correct. Can you see? You're losing marks because of a simple, small mistake. That 3 is going to help you to get 70, or it's going to get you to get 80. But because you didn't put C there, then you do what? You lose marks. Are we together, grade 12s? Yes. Let's continue, grade 12s. The second example. Can you see the second example? It says, what is the capacitor, capacitance of the capacitor that receive a charge of 0.005 coulomb when the voltage is how much? Is 300 volts. The same way we did with the first example, we're gonna do it. We're gonna do here. First, what is given? We're given C, 0.05. Oh, sorry, grade 12. This is not C, ne? Oh, it's C. Yes, it's fine. It's fine. Okay. Now we're given what? We're given a charge of 0.05. Are we together? And we're given a voltage of 300 volts. Are we together? Then we do as we did before. We write what? Data, and then we say Q is equals to 0.005 coulomb, and then V is equals to 300 volts. And then what are we asked to calculate? We are asked to calculate what? Capacitance, which is what? C. We're going to put what? Question mark from there. Are we together? Then what we do is what? We're going to say C is equals to, the formula says C is equals to Q over V. This is the formula that we get from, again, from what? The formula sheet. Are we together, grade 12? Yes. Then we say, now, we need to do what? Substitute. When we substitute, we're going to substitute what? We'll write C as it is. Are we together? Because we don't know how much is C. Then we say C is equal to 0.005 divided by what? 300. Are we together? Then from there, this is not wrong. The formula that we have here, this is what? A wrong formula. The formula must look like this next. Are we together, grade 12? I like to apologize for that. And then from the calculator, we press what? 0.005 divided by what? 300, which gives us what? Which is going to give us 0.0000166 recurring. That means this is the answer, and it is in what? Farad. Don't forget, the unit for capacitance is what? Is farad. Are we together, grade 12? Yes. Then this answer can be written as 1, comma 66 times 10 to the exponent 1, 2, 3, 4, 5 to the exponent 5 farad. Are we together, grade 12? Yes, you can write it, you can leave it the way it is, or you can write it in what? Sigma notation. Are we together, grade 12? Yes, I know that you did sigma notation from grade 10. Né? Yes, let's continue, grade 12. If you have any question, please WhatsApp us on 063 629 3655. Okay, we have the third example. Example number 3, it says, what is the capacitance? What is the capacitance of the capacitor that receives a charge of 0.001 coulomb when the voltage is what? The voltage is 20 volts. Are we together? And then I would like to, let's overlook this one now. Let's do it from the beginning now. We said from this formula, I just want to show you the formula. The formula that we are using at grade 12 is this one here. Can you see? It says C is equals to Q over V. That is the formula that we use now. We made a mistake here by using a wrong formula. It says the formula, it says what? C is equals to Q over V is not this formula. Are we together? Then we say from here, what we did in example 1 and example 2, we continue with that. Now, we're going to say what? We're going to say, write down what? Data. We write down data where we found that Q is equals to 0.001 coulomb, and then V voltage is equals to 200 voltage. Then C is unknown. Then from here, we just do what? We just substitute. Q is 0.001 divided by what? 200, which is going to give us what? Don't be afraid to use a calculator, grade 12s. 0.001 divided by 200. It gives us what? 0.00005. Are we together? Then which is the same farad, which is the same as what? C is equals to what? 5 times 10 to the exponent 1, 2, 3, 4, 5, 6. Farad. Are we together, grade 12? Yes. Okay. If you have any question, please WhatsApp us. We'll look into your question and we'll respond to your question. Are we together, grade 12? Yes. Now we go to, I like this question because it deals with what? It deals with the factors that affect the capacitance. Are we together? They say consider the following 4 variables. The first one is current between plates. We have a distance between plates, type of dielectric material, and total surface area. And they said which of this affect capacitance of the capacitor? Which one affects? Factors affect. Are we together? At the factors, we dealt with what? We dealt with the distance, isn't it? We dealt with the type of dielectrics and what? The surface area of the plates. Are we together? And then that means we never dealt with current. Are we together? That means our answer is what? B, because B is the one that has 2, 3, 4. 2, 3, 4. Are we together, grade 12? Yes. 2, 3, 4. Ne. Yes, grade 12. Let's continue. We have another example here, but at this moment, we'll be using a different equation. Remember, we've been using C is equals to Q divided by V. Then at this time, we're using another formula that is given on the information or a formula sheet. Okay. Sorry for that, grade 12. A capacitor is constructed. The question says a capacitor is constructed from two conductive metal plates 0.05. The metal plate, it has the length and the breadth of 0.05 and 0.1 meters. Are we together? Then this, what you see here, it will help you to calculate what? The area of the plate. Are we together? Yes. And they said which are spaced. The distance, that means when it says which are spaced 0.04 meters apart, that means the distance between the capacitor is what? Is 0.004. Are we together? Yes. And then from each other, the space between from two plates is what? 0.004 meters, and is used dry air. Are we together? When they say it's used dry air, we saw that from this table here, from this table here, you can see the air is equals to 1. Are we together? Air is equals to 1. That means K for air is equals to 1. Let's go back to our question. Then we say we're using what? The dielectric is what? It's a It's the dielectric is a dry air. Are we together? Now they use a dry air as a dielectric material. Then we know that K is equals to 1 for dry air. Then they say calculate the capacitance of the capacitor. Are we together? I don't want to focus on this one. I just want to focus on this formula. C is equals to K 0 A divided by what? Divided by D. Let's start. Now, the given data that we're given is what? We're given what? Data. It will be equals to what? Length is equals to 0.1 meter and breadth is equals to 0.05 meter. And then we're given what? D. The distance between the plates is equals to 0.004 meters. Are we together? And we know that our epsilon E subscript 0 is equals to the permeability of a free space is equals to 8,85 times 10 to the exponent negative 12. Are we together? Grade 12. Then K here at this instant is equals to 1. If you multiply everything by 1, it doesn't change. It's the same thing. That means at this instant, the reason why they use this formula, not this, because they know that K, it doesn't make any difference because K is equals to 1 doesn't make any difference. Are we together? It's the same as you're using here, because even if you can put K here, it's not going to make any difference because K is equals to 1. Are we together? Then, from the data, because when you look at the formulas, we have area gap. We don't have length and we don't have breadth. That means we need to calculate what? A. Our A area is equals to length multiplied by what? By breadth, which is equals to 0.1 multiplied by 0.05, which is going to be how much? 0.0005 meter squared. Are we together? That is going to be our area. Let's make sure 0.1 multiplied by 0.00 or 0.05, which is going to give us, yes, 0.005 meter square. Can you see grade 12? Every time at the final answer, I put my units. Here my units is what? Is meter square. Can you see? Thank you very much, grade 12. Then, what we do is what? We can, after you calculate that, then we can substitute. We can go back and say C is equals to K epsilon 0 A divided by D. Then when we substitute, we're going to say K is equals to what? 1 again. Multiply by 8.85 multiply by 10 to the exponent negative 12 multiply by 0.005. Are we together? Divided by what? Divided by 0.004, because this is the distance again. This is the distance. Are we together? And then this is epsilon, and this is the area that we just calculated. Are we together, grade 12? Yes, this is the same as this area. You can use this method, or you can use this method. Is you're still gonna get what? The same answer, which is equals to what? 1.11 times 10 to the exponent negative 11 farad. Are we together? The unit for capacitance is still what? Farad. Are we together? Yes. Let's continue grade 12. Another example, it says what? Suppose you wish to construct a parallel plate capacitor with a capacitance of 4 times 10 to the exponent negative 9. What area must you use for each plate if the plates are separated by what? By 0.006 meters. Can you see the data that we have here is what? Data is what? We have what? Capacitor, which is 4 times 10 to the exponent negative 9 farad, and the D, which is the distance between the plate, is 0.006 meters. And then what I'm looking for is what? Is the area. We are calculating what? Area of the plate. Can you see from the formula? We took the formula from the information sheet, the way as it is. We didn't change anything. Then we substituted that E subscript 0 is what? 8.85 times 10 to the exponent 12, and then multiply by A. Because we don't know how much is A, we just leave it as it is. Then we divide by what? 0.006, which is the distance between the plates. Then after that, we manipulated it and make the A the subject of the formula. Then we got the answer as 2.71 meter square. Can you see? I always put my units. I don't forget my units. Okay. Grade 12. We have a problem here that we need to look at. It says here, a capacitor has a capacitance of 2 times 10 to the exponent negative 10 farad. The charge on the plate of the capacitor is 4 microcoulomb. What you see here is, it means micro. And micro grade 12 is equals to 1 times 10 to the exponent negative 6. Are we together? Always when you see micro, you must know that is what? It's equals to 1 times 10 to the exponent negative 6. Are we together, grade 12? Yes. Then, from here, the first question says, define the term capacitor. What is capacitor? Capacitor, we know that is a device that can store electrical charges. Are we together? Is the device that can store electrical charges. Are we together? And then number 2, they say, firstly, let's write down data. Data is what? C is equals to 2 times 10 to the exponent negative 10. And Q is equals to 4 times 10 to the exponent negative 6 coulomb. Are we together? Those are 2. Because of micro, we say times 10 to the exponent negative 6. Are we together, grade 12? Yes. Okay, now, question number 2, they say, calculate the potential difference in volts across the capacitor. Grade 12, don't stress. When they say potential difference is the same as what? Voltage. Are we together? Potential difference is the same as what? Voltage. Now, that means we'll use the same formula. C is equals to Q over V. And then we say substitution is what? 2 times 10. We can see here, number 2. Let's look at, we said here, the solutions for that question. The question 1, they said, do what? Define capacitor. And then we say capacitor is a device for storing electrical charge. Are we together? Then number 2, they ask you to calculate what? The potential difference, which is the same as the voltage. You can see we're using the formula, this formula, and then after using the formula, remember the data that were given is what? Is C is equals to what? Is 2 times 10 to the exponent negative 10, and the charge is equals to 4 times 10 to the exponent negative 6. Farad and Coulomb. Are we together? Then we just take, and then the V is unknown. That means this time we need to calculate what? The V from the formula. Then when you look there, you can see that we have managed to substitute. This is the C and this is the charge. Can you see? Then we do what? Manipulated. We just take V, this, that, and this one comes down here. Then we have our answer as 2 times 10 to the exponent 4 volts. Are we together? Are we together, grade 12? Yes. That is our final answer. And then we go back to look into our question again. Our question says, calculate the total surface area of the capacitor if the distance between the plates is 3 millimeter. And air is the dielectric. Can you see? We're using air as a dielectric. The reason why they don't give you the K constant of air is because they know that K is equal for air is 1. You don't have to memorize it, and then you just need to know that K for air is what? Is 1. Are we together? Then when we go to our solutions, this is the formula. Data that we're given is what? We know that C is equals to 2 times 10 to the exponent negative 10. It didn't change. And then epsilon 0 is equals to 8.85 times 10 to the exponent negative 12. And then now D, which is the distance between the plates, is equals to what? It's equals to, the set is 3 millimeter. Are we together? Because we always look at the distance in meters, we need to convert 3 millimeter into meters, which we divide by what? by 1,000. Then we're going to get 0.003 meters. Are we together? Yes, grade 12. Yes. Okay, let's continue. We substituted everything that we have there because we were asked to calculate what? We were asked to calculate area, then we leave area as it is. Are we together? From this formula here, we substituted C, we substituted E is subscript 0, then we substituted the distance. We're left what? AE as it is. Are we together? Because you calculated it, and thereafter from here to here, we manipulated and make AE the subject of the formula. Are we together, grade 12? Then from there, we use a calculator, then we get 0.07 meter square as our area of each plate. Are we together, grade 12? Yes. I want us to look at this one. Okay, this one also. This one, it says the charge on the plates of a capacitor is what? Is 2 microcoulomb. Is what? 2 microcoulomb. And the potential difference across the capacitor is 10,000 volts. Grade 12, I'm just going to give you 1 minute to copy down the questions. I'm going to give you 1 minute to copy the questions down, and we'll come back to look into the solutions. Are we together? These questions, grade 12, they come from previous question papers. It is very, very important that you go through them, you practice them now and then. Thank you. We'll meet after 1 minute, grade 12. Okay, welcome back, grade 12. Hope that you managed to copy down the questions. Let's go through these questions together. It says the charge on the plates of a capacitor is 2 microcoulomb, which we know that 2 microcoulomb, it means 2 times 10 to the exponent negative 6 coulombs. Can you see? I write 2 times 10 to the exponent negative 6. Then I don't write this because this micro is represented by this. Are we together? Yes. And the potential difference across the capacitor is 10,000 volts. Are we together? Yes, grade 12. Now, we say, calculate, the first question it says, calculate the capacitance of the capacitor in its basic SI, units. Can you see how many marks? For 4 marks. Are we together? Then let's go and check how much are we having. First thing, the data that we're given is what? Data. It says that the charge is equals to 2 times 10 to the exponent negative 6 coulomb. Remember, it was a microcoulomb. Then we change it to to numbers. Then we're given the voltage, which is 10,000 volts altogether, which is the same as potential difference now. Whether they're gonna ask you to say, sometimes they'll say voltage, sometimes they'll say potential difference, but you must know that it means the same thing in the capacitor. Are we together, grade 12? Yes. Now we're saying after we wrote down the data down, then we're able to do what? We copy down the formula as it is from the information sheet or the formula sheet, and then we're able to substitute. Are we together? And you can see that this is the formula. To write down the correct formula, you have 1 mark. Are we together, grade 12? And then the substitution, that means it's going to have 1 mark there and 1 mark there. Are we together? And the final mark, we're going to get another mark, and that gives you 4 marks. Are we together, grade 12? Yes, that is how we mark this. And the reason why we're giving mark here is because you managed to change the microcoulomb into a scientific notation. Are we together? Yes. Let's go back and check the second question. What does it say? The second question, what does it say? Are we together? The second question says, calculate the distance. Okay, they said the distance between the plate is 1.5 millimeter. When you see millimeter, you must always think of what? Conversion. You must convert millimeter into meters. Are we together? You must convert millimeter into meters. And the air, can you see? They always use what? Air, because air is equal to K for air is equal to 1. It doesn't make any change from our formula. Are we together? Even when you substitute 1 or you don't substitute it, it doesn't make any difference because it's equals to 1. Then they ask you to calculate what? The surface area. Are we together? You are asked to calculate the surface area. Because you have already written down the data, we know that Q is 2 times 10 to the exponent negative 6, V is 10,000, and then we know that this one is 8.85 times 10 to the exponent negative 12. And then also D, they said is how much? 1.5 millimeter, which is the same as what? 0.0015 meters. Are we together? 0.0015. Are we together? Which we divide millimeter 1.5 by 1,000 in order to convert to meters. Are we together, grade 12s? Yes. And then because we have all this data, we are able to write down the formula. Does this formula look familiar for you? To you? Yes. We saw it on the information sheet. Are we together? Or on the formula sheet. Then you are able to substitute everything. Are we together? Then we're going to start with what? C. You can see. C here is going to be 2 times 10 to the exponent negative 10 because we have calculated it here. Are we together? We're going to use the same capacitance on this formula. Then you see this value is the same as this. Can you see, grade 12? Yes, they are the same. We just took what we have there and we put it here because it's C, it's capacitance. Are we together, grade 12? Okay, now we continue to substitute. We substituted this. This is this. Can you see? And then we left A as it is because of what? It doesn't change. It is what we are calculating for. Are we together? It's what we are calculating for. We can't, because we don't know how much is A as yet. We don't know how much is A yet. Then we need to calculate A. And this one is what? Is D, which is the distance between the plate. Are we together, grade 12? Then thereafter, we made A the subject of the formula. Then we use the calculator in order to get the final answer, which is 0.024 meter squared. Are we together, grade 12? Yes. Any question, grade 12, please forward it to 063 629 3655. Are we together? Yes. Let's go back to our questions. Now, the question number 3, it says, how does a decrease in distance B between the plates affect the capacitance if all other factors remain constant? We don't change any other factors. We're only changing the distance between the distance between the plates. Choose your answer. If we decrease, remember, we're making the distance smaller. Are we together? We're making the distance smaller. Then they say you choose your answer from increase. Will the capacitance increase? Or will it remain the same? Or will it decrease? And they say, explain your answer. Why are you choosing that answer? Okay. Let's see. The answer is what? If you decrease the distance between the plates, you are increasing the capacitance. Why? Because the distance and the capacitance are inversely proportional to each other. Let's look at this formula. C is equals to over D. Can you see D is inversely proportional and A is directly proportional? Are we together? That means when you decrease the distance, you are increasing what? The capacitance. Are we together? You are increasing the capacitance. Are we together, grade 12? Yes. Now, let's go back to the questions. Question number 4. It says, give one example where capacitor is used in technology. Give one example where capacitor is used in technology. We have 3 ways where we can use what? We can use the capacitor. One of these is correct. You only need to give one. You don't need to give 3 of them. I gave 3 of them because I want you to choose from one of these. Are we together? The filter circuit in power supply, that is 1. Separation of frequency between the Hoover, speaker, and tweeter. And the last one is speaker or electronic noise filtering. Are we together, grade 12? Any question? Just send it to us on WhatsApp 063 629 3655. Okay, grade 12. We have another problem which I want you to look at, and we'll do it together again. Are we together, grade 12? Yes. I'm going to give you 1 minute again to look into the problem so that you are able to copy it down or take a snapshot of it. Next, grade 12, then we'll come back after 1 minute. Welcome back, grade 12. Hoping that you managed to copy the questions down. Remember, these questions, they come from a previous question papers. They are very, very good for practicing. Are we together, grade 12? You can take a snapshot or you can copy them down. You can write them down. Okay, let's go through the questions together. A capacitor has a capacitance of 2 times 10 to the negative 10. 2 times 10 to the negative 10 farad. The charge on the plates of a capacitor is 4 microcoulombs. Are we together? And then that means, this is what it means. It means that we have C is equals to 2 times 10 to the exponent negative 10 farad, and Q is equals to 4 times 10 to the exponent negative 6 farad. Are we together? Then, this is only 2 data that were given, 2 values that were given. Okay, now, grade 12s. The first question, it says, calculate the potential difference in volts across the capacitor. Potential difference, remember, is what? It's a voltage. Are we together, grade 12? It's a voltage. Then, that means our V here is going to be what? Unknown. Are we together? We don't know how much is it. Then we need to put what? Question mark under data. Then, when we choose the formula that we must use, we look into the given data. We choose the formula that have all 3 letters. Like here we have a C, we have a Q, we have a V. Which formula are we supposed to choose that have a C, that has a Q, and that has a V? Is only one formula which says C is equals to Q over V. Are we together? You can see the given data helps you to choose the correct formula. If you copy them down, they help you to choose the correct formula. Are we together, grade 12? Yes. And then now, because we have chosen the correct formula, we are easily substitute. We can easily substitute. We know that C is equals to 2 times 10 to the exponent negative 10 is equals to, charge is equals to what? 4 times 10 to the exponent negative 6. Then divide by what? Divide by V. Then what we do is what? We manipulate this substitution and make V the subject of the formula. How do we do that? Multiply by V this side, multiply by V this side, then this V will cancel this V, then we'll have 2 times 10 to the exponent negative 10. V is equals to 4 times 10 to the exponent negative 6. Then we divide both sides by 2 times 10 to the exponent negative 10. Divide both sides by 2 times 10 to the exponent negative 10. Then this will cancel this. Then we're left with what? V is equals to 4 times 10 to the exponent negative 6 divided by 2 times 10 to the exponent negative 10. Can you see? Then, now we can take our calculator and calculate. We say 4 times 10 to the exponent negative 6 divided by 2 times 2 times 10 to the exponent negative 10, which gives me how much? 20,000. It gives me 20,000, which is the same as what? 20,000 volts, ne? 20,000 volts, which is the same as 2 times 10 to the exponent 1, 2, 3, 4 to the exponent 4 volts. Are we together, grade 12? The answer is 2 times 10 to the exponent 4 volts, or is equals to 20,000. Are we together? Yes. And then we go to number 2, second question now. Second question, now, because now we calculated V, we found that V is equals to 2 times 10 to the exponent 4 volts. We can put it under given data. Are we together, grade 12? Yes. Now question number 2, they say, calculate the total surface area of the capacitor if the distance between the plates is 3 millimeter. And we're using what? Air resistance. Are we together? Then, from here, what are we going to do? From here, what are we going to do? We just say what? We just say, use the same formula, which says C is equals to epsilon 0 A divided by what? Divided by D. Then we substitute, because they want what surface area. We know that C is how much? Is 2 times 10 to the exponent 4, which is equals to 8.85 times 10 to the exponent negative 12. Area divided by D is how much? D, the sec, is 3 millimeter, which is the same as what? 0.003. Now, because we take 3 millimeter, we divide by, to convert it from millimeter to meters, we divide by 1,000. Are we together? Then we divide by 1,000, then we got 0.003. Then we do what? We make A the subject of the formula. When we make A the subject of the formula, then you'll find out that now A is equals to 2 times 10 to the exponent 4 multiplied by 0.00 multiplied by 0.003 divided by what? Divided by 8.85 times 10 to the exponent negative 12. And then we take, after we did that, then we can take our calculator and starting to do what? To calculate. We say 2 exponent 4, or 2 times 10 to the exponent 4, multiply by 0.003. Then divided by what? 8.85 times 10 to the exponent negative 12, which gives us how much? It gives us area is equal to 6.77 times 10 to the exponent 12 meter square. Are we together? This is what we have. This is what we have. Are we together? Yes. And then the third question, it says, how does increase in the distance between the plates affect the capacitance if all other factors remain constant? How does that? Remember the first time we said, how does decrease in the distance? Now we're saying, how does increase in the distance will affect the capacitance? The same way, grade 12, we say capacitance is equals to, we write down the formula the way it is. We know that this D is for the distance, and because capacitance and the distance are inversely proportional, then what we need to do is to do what? We say, what will happen if we increase the distance? When we increase the distance, that means the capacitance will become what? When we increase the distance, the capacitance will become less. Are we together? Increasing the distance, it makes the capacitance to be less. Are we together? And then it makes sense, because if you're moving the plate farther away, then the charges, you can't store more charges because of what? The plates are more. The charges can move from one plate to another because the plates are far from each other. Are we together? That means it will affect what? The capacitance. Are we together? This is what the reason that you can give. You're saying what? Because the distance is inversely proportional to the capacitance. Because what? Because the distance is inversely proportional to the capacitance. Then the capacitance increasing the capacity, increasing the distance will decrease the capacitance. Let me say it again. Because the distance is inversely proportional to the capacitance, then increasing the distance between the plates will decrease what? The capacitance. Because inversely proportional, always when you hear inversely proportional, you must know that one is going up, another one is going down. Are we together? One will increase and the other one will decrease. Are we together, grade 12? Inversely proportional, one is going up, the other one is going down. One will increase, the other one will decrease. Are we together, grade 12? Yes. That is how inversely proportional does. That is how the relationship, it will give you the relationship between the distance and the capacitance. Are we together? It gives you the relationship between what? The distance and the capacitance. They stated that any other factors will remain the same. That means the area doesn't change, and we know that this will not change because it's a constant. It remains the same every day. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, it will be equals to 8.85 times 10 to the exponent negative 12. It doesn't change. Are we together? It doesn't change. It will always remain the same. Are we together, grade 12? Yes. Let's go to, okay. I want us to go back at this. I know that it's very, very difficult to make. I want us to go back to this, question 2. To question 2, when we're calculating the surface area, we said our given data is what? Is capacitance is equal to 2 times 10 to the exponent negative 10. And then our charge is equal to 4 times 10 to the exponent negative 6. Are we together? Farad coulombs. And then we found that the voltage is equal to what? The voltage is 4 times 10 to the exponent 4. Is it 4? No, 2 times 10 to the exponent 4 volts. Then we're given what? The distance to be 3 millimeter, which is the same as 0.003 meters. Are we together? And then we substituted everything on this formula. C is equals to over D. Then we set 2 times 10 to the exponent 10 is equals to 8.85 times 10 to the exponent negative 8, negative 12, A divided by 0.003. Then in order to make A the subject of the formula, that is the tricky part that I want to get to. We start by multiplying both sides by 0.003. Again, multiply by 0.003. Can you see? Then this will cancel this. Then we left with what? We left with 0.003 times 2 times 10 to the exponent negative 10, which is equals to 8.85 times 10 to the exponent negative 12. A. Are we together? Then from here, we divide by 8.85 times 10 to the exponent negative 12 on both sides. Are we together? Remember what you do on the left, you also do on the right. Are we together? Then 8.85 times 10 to the exponent times 10 to the exponent negative 12. Then this will cancel this. Can you see? Then on the right, you are left with only a. Then on the left, you have what? 0.003 times 2 times 10 to the exponent to the negative 10 divided by 8.85 times 10 to the exponent negative 12. Then from there, you can use your calculator, then you get your answer. Are we together, grade 12? Yes, I just want to clarify that. Then we come to the end of our lesson. I hope that you learned a lot. Yes, please remember that COVID-19 is still with us. Take all the precautions. Thank you very much. See you next time.